Today is a jam-packed day. Not only do we have all that is new in space and astronomy, but we will also be joined later in the show by Fraser Kane, the publisher of Universe Today, to talk about the changing landscape of space news. For now, though, let's jump out to look at a big galaxy in the Hubble Deep Field.
As we head into year two of pandemic lockdown, I for one know it's time to buy new yoga pants in maybe a size larger. Let's face it, sometimes things just grow. But before any of us should start to feel bad about our personal mass enhancements, we just need to put everything in perspective. No matter how many random Oreos I may eat, my gains are insignificant compared to those of galaxies in the early universe. Back in 1995, the Hubble Space Telescope pointed at what was believed to be one of the blankest regions of the sky. It looked at that patch for 10 days. The goal was to see just what faint objects might be out there, otherwise lost in the light of all the nearer or brighter objects. The answer was galaxies. This tiny field contained over 3,000 galaxies. And one of those galaxies, HDF 850.1, is a massive star-forming system 12.5 billion light years away. This galaxy is putting on stars at a rate of a few hundred solar masses of stars per year. This is the highest known star formation rate ever seen. A new paper by Rosie Calvi and Company, appearing in monthly notices of the Royal Astronomical Society, looks at the environment around HDF 850.1 and finds 23 observable companion galaxies and a complex structure around it. These systems are thought to be just the brightest members of a massive galaxy cluster forming in the early universe. Over time, these galaxies will interact and move together to form a cluster that, if we could see it today, it would probably look a lot like the nearby Virgo cluster. Put another way, this massive system is so massive it has gravitationally pulled in its neighbors while spitting out hundreds of stars a year. I suddenly feel much better about my personal growth over the last year.
From massive galaxies, we now turn toward massive stars and an easy-sounding problem that has turned out to be quite hard. Also, this research article came with a really pretty picture we wanted to share. Long story short, researchers have been struggling to find ways to accurately measure the temperatures of red giant stars like Betelgeuse in a consistent manner. These stars have complex atmospheres that are highly variable, and many of the normal ways we have for measuring a star's temperature don't work so well with that chaotic atmosphere. We need to know stellar temperatures, however, to make sure our models describing how these stars live and die as violent supernovae are correct. Well, iron has come to the rescue. This particular atom can be found in the outer parts of stars and is highly sensitive to temperature. Like all atoms, iron absorbs light at specific colors, and how much light it absorbs at each color depends on temperature. By comparing how much light is absorbed at different colors, researchers from the University of Tokyo have been able to accurately measure the temperatures of red giants and determine that theory and reality match nicely. As for this stunning image, that red asterisk of light is the star Betelgeuse. Next time you look at the constellation Orion, know that the entire region is rich in these clouds of star formation, and the stars we see are just the brightest sampling of what's out there.
What we see with our eyes is just the faintest tracing of everything going on in the sky. And it's often the accidental discoveries that are the most memorable. Recently, researchers using the Juno mission's ultraviolet spectrograph were purposefully observing aurora around Jupiter when they accidentally observed a bright meteoroid explode in Jupiter's atmosphere. The explosion took place about 140 miles above Jupiter's cloud tops, and its brightness was consistent with an object between 550 and 3,300 pounds. Basically, a car-sized rock exploded above Jupiter and was caught on camera in the process by accident. We used to think these kinds of events were rare, with the 1994 impact of Shoemaker-Levy 9 into Jupiter being the first broadly observed impact. We're now learning they aren't so much rare as generally brief in duration, and unless you happen to be watching Jupiter at just the right moment, they tend to go unnoticed. Remarkably, most impacts like this are spotted by amateur astronomers. You never know exactly what you could discover by looking up.
And sometimes you have to look down to understand what you might someday find when you look up. Researchers from the University of Rhode Island's Graduate School of Oceanography have published a new paper in Nature Communications describing how life living beneath the seafloor can survive off chemicals released through radioactive reactions. Specifically, naturally occurring radiation can split water molecules into hydrogen and oxidants, and this process is much more effective in seafloor sediment than in open water. According to Stephen Daunt, a co-author on this study, if you can support life in subsurface marine sediment and other subsurface environments from natural radioactive splitting of water, then maybe you can support life in the same way on other worlds. Some of the same minerals are present on Mars, and as long as you have those wet catalytic minerals, you're going to have this process. If you can catalyze production of radiolytic chemicals at high rates in the wet Martian subsurface, you could potentially sustain life at the same levels that it's sustained in marine sediment. As a reminder, marine sediment is extremely rich in microbial and other life, implying Mars could be rich in tiny life forms just waiting to be found. Percy, we're looking at you. Please go find fossils of past life that will let us know if we should go looking for current life. After the break, we'll be back to talk about the Trojan asteroids, and we'll have an interview with Universe Today publisher Fraser Cain on the changing landscape of science news. Stay tuned. Our next story is one for both the astrophotographers and the planetary scientists, but not for Pamela, because I'm going to discuss a mission that hasn't launched yet. That mission is Lucy, which is a NASA Discovery Program mission to explore 7 Trojan asteroids and a main belt asteroid. It's a 12-year mission, and the launch window opens up on October 16th of this year. So, what are the Trojan asteroids? How did we find them? Here is where the astrophotography comes in. In the late 1800s, German astrophotographer Max Wolf had already made a name for himself at the ripe old age of 21 by discovering his first comet. At 27, he decided to search for new asteroids using wide field photography, the first person to attempt such a feat. Within 2 years, he had found 18 new asteroids. After that, he became the first person to use a stereo comparator, which is like a viewmaster, that helped make those asteroids more easily visible against the background of stars. Then, in 1906, Wolf found an asteroid with what appeared to be an unusual orbit. It remained ahead of Jupiter as Jupiter moved. Another German astronomer, Adolf Berberich, confirmed the discovery and noted that the asteroid's orbit was about 60 degrees in front of Jupiter. And here is where work by Joseph Louis Lagrange comes in. I'm sure a lot of our regular viewers are familiar with Lagrange points, but let's give a quick summation for those of you who are not. Lagrange was a mathematician who theorized that a small body, like an asteroid, could be caught in the same orbit as a planet if it ended up at one of 2 stable points in that orbit, what we now call the L4 and L5 Lagrange points. Essentially, at 60 degrees ahead or behind, the smaller body benefits from the combined gravitational forces of the planet and the sun. If you could stand on Jupiter, these asteroids would look like they weren't moving. Up until Wolf's discovery, Lagrange's work was purely mathematical. Now astronomers had photographic evidence. Within a few months, 2 more of these Lagrange point asteroids had been discovered by other astronomers. And now that there were several, it was time to give them a name. Remember, astronomers like objects to fit into boxes, and then we name those boxes. Most of the asteroids in the main asteroid belt have been given the names of women from Roman and Greek mythology. Think Ceres or Vesta. So Austrian astronomer Johann Palisa suggested that these new Jupiter asteroids be called Achilles, Patroclus, and Hector after characters in the Iliad. And so a naming convention was born. But not quite. Here's where the story gets fun, and I'm going to quote a NASA article because it's perfect. As astronomers continued discovering asteroids hiding in Jupiter's Lagrange points, they continued naming them after heroes of the Trojan War and began referring to them as Trojan asteroids. Trojan asteroids would eventually refer to asteroids inhabiting any planet's stable Lagrange points, though names from the Iliad are reserved for Jupiter's Trojans. It later became convention to name Jupiter's L4 asteroids after Greek characters and Jupiter's L5 asteroids after Trojan characters. So L4 and L5 became the Greek camp and the Trojan camp, respectively. Palisa apparently did not foresee this tradition, for his naming of the first three asteroids led to a Greek spy residing in the Trojan camp, Patroclus, and a confused Trojan, Hector, who probably wandered into the Greek camp hoping to order some of their famous custom-built wooden horses. These Trojan asteroids are thought to be the remnants of the material from which our outer planets formed. Some resemble icy bodies found in the Kuiper Belt, some resemble main belt asteroids. All are thought to have an abundance of dark carbon compounds, as well as an insulating blanket of dust that covers a wealth of water and other volatiles. Now, for the first time, we are sending a mission to study some of these Trojans, including Patroclus. The Lucy spacecraft is named for the skeleton of a human ancestor whose discovery led to breakthroughs in our understanding of human evolution. The spacecraft is expected to do the same for our understanding of planetary formation and evolution here in our solar system. After Lucy's launch, the craft will use boosts from Earth's gravity to travel between the L4 and L5 Trojans, targeting 7 asteroids in total, including one main belt asteroid, Donald D. Johansen. The initial mission will take 12 years to complete, and after that, Lucy will continue to cycle back and forth between the 2 points every 6 years. We're excited for this launch, and we'll keep you up to date on the timeline here on Daily Space. When we return, Pamela will be joined by Fraser Cain, publisher of Universe Today, to talk about how science news is changing.
Hello, everyone, and welcome back. I am now joined by my longtime co-host of Astronomy Cast, Fraser Cain, publisher of Universe Today. How are you doing today, Fraser?
Very well. I'm enjoying watching somebody else report space news. It's great.
So I was trying really hard to figure out how best to introduce you. And I had the realization in the process that you have been communicating space news online since people actually weren't ashamed to have AOL accounts.
Yeah, 21 years.
So your Universe Today site dates back to the days of dial-up, and you have been here to see the transformation from the majority of media coming to us here on television to the majority of news coming to us on the internet. And
Social media now.
yeah,
Yeah.
and where we get news has radically changed. How we turn up stories has radically changed. And I'm hoping that you can start off by saying what it was like back in those early days of the internet and how things have changed over the years. So how did it start? What brought you to this Babylon 5 named behemoth of space news that you are today?
Well, okay. I think people know my origin story fairly well. The domain name, even back in 1999, there weren't a lot of domain names available that were
Yeah.
good. And so I just took all of the space names and all of the time domain names, put them together one after the other, checked them all against available domain names and bought the one that I liked the best. So it could have been Cosmos now, but it ended up being Universe Today. So there's no rhyme or reason to the actual name, and I learned later that it matches the newspaper in Babylon 5. But hopefully, I have been using it long enough that it's been clearly mine as well. how I got into it, I used to work as a web developer for a big company in Vancouver. We were doing banks, hydro companies, lottery, discount trading houses, fairly big and institutional clients. And I had a lot of wacky ideas, which Pamela can probably confirm all the time. And nobody would listen to me. And so I said, okay, well, you know what? I'm going to build my own website. I'm going to practice all of my wacky ideas, see which ones are good, which ones are bad, throw out the ones that don't work, and apply the ones that work to my clients. And it worked like a charm. I, developed Universe Today, picked one of my hobbies. I happened to be reading Pale Blue Dot and The Case for Mars at the time, had been super into space all my life. And so I said, okay, I'll do a website about space. Learned a ton about running a website, that it's not about building the website. It's about day after day after day showing up and keeping things fresh and updated. And I brought all these lessons back to my clients, but I also said, okay, I'm only going to do this for the rest of my life. Like I'm having so much fun that now it's a question of when can I escape the rat race and when can I just do Universe Today forever? And, we were able to live cheap, do some advertising, live off some of our savings, and I was able to go it alone. So that's been, and like I said, I started the site in 99, probably went full-time, or probably cut the chains in like 2001. And I think I've been earning a reasonable living from it since maybe 2005. Brought on more people by 2007, 2009. And now I think we have 15 plus writers on Universe Today.
And how we keep track of what all is going on in the universe has radically changed in those years. You have been around for the emergence of social media. You've been around for the emergence of new media, which actually came out in the opposite order.
Yeah.
And it went from news was what you got in press releases and from looking at the journals to news is what some random grad student is excitedly tweeting about as their team publishes a paper.
Yeah, absolutely.
What have you had to take into account as you change to follow where the stories are?
Well, when I started, all of the big media companies had either a specific space reporter or a science team that was capable of reporting on big space news. They would send people to the Cape to film space shuttle launches. They were at big press conferences for the Hubble Space Telescope. They were at NASA for, there was a lot of coverage in old school media. So I started really just covering what they were covering.
Okay.
And so I would, if ABC was reporting that some interesting piece of space news had happened, I would report that ABC News was reporting this. And then I said, okay, well, how do they know? How did they learn this? And so then I would follow these to the source, because they would say, oh, based on a press release from this university. I'd be like, oh, okay. And then I would go to that university. I would see the press release and I would go, okay, now I can just follow the press releases from this university and find out how this is being done. And so within a couple of years, I was able to get past all of the middlemen and get to the source of most of the news. But then every now and then someone comes up with something that you haven't seen before. And you're like, wait a minute, how did you know about this interesting piece of research? And I'm like, oh, it was in a paper. Okay, now I have to understand where all the papers come from. And so I found AstroPH and Astrophysical Journal and all that, and check all those. And that takes you sort of way closer to the source. But still, things would be happening that I was like, where did this come from? Because it was announced at a conference or announced at at some get together. And so I would then now start to troll all of the conferences, all of the different papers, all of the different keynote speakers, what they were going to be saying, and be able to digest and incorporate that. And so about, in the rise of Twitter was the first time there was sort of like a new source of interesting stuff was finding its way into the newsfeed. And I had no idea kind of where it was all coming from. And that's a much trickier one to sort out, because you can have Elon Musk post on a tweet that they've got an idea for a brand new spaceship. and there's not going to be any press release that covers that. So in the modern age, now that I sort of look at all the press releases, I look at all the journals, I look at all of the conferences that are happening, and then I have to layer on top of that, what's the chatter? What's the interesting things that people are talking about? And my goal is to get there and find the stuff that nobody is aware of, nobody's thinking of, and that there's really no coverage of. That's, like, I'm less enthusiastic to talk about Perseverance landing on Mars, not because I'm not stoked for Perseverance. And we did, I think we're at 5 or 6 or 7 stories so far about Perseverance on Universe Today so far, just after the landing. But I know it's going to be well covered. I feel like Perseverance's story is being well told. I'm interested in the people that are building robots made of ice. I'm interested in the people who are planning on building telescopes out of local materials on the backside, on the far side of the moon. So my job now really is to just dig into every nook and cranny of the science that's going on and reveal the stories that are fascinating to me, that I think are important, that I think are getting less covered.
That is amazing. And when we come back from break, we're going to talk more about how it's possible to take a ragtag group of baby journalists and turn them into one of the, well, powerhouses for astronomy news. So we'll be right back. Stay tuned. Hello and welcome back to those of you just joining us. My name is Dr. Pamela Gay, and I am joined today by the publisher of Universe Today, my collaborator of many years on Astronomy Cast, Fraser Cain. So we now live in this amazing work from home environment that you and I have actually been doing for forever.
Doesn't feel any different.
Exactly. And I feel kind of like we're designed for these crazy modern times that we live in. And you're showing how you can work without any buildings, without any art department, with a group of humans.
Yeah.
At what point did you realize you could take on the big publishing?
Well, I had always assumed that big publishing was going to take on itself and wipe itself out of existence. So I never felt like it was my job to take them on. I could see that as they laid off their science reporting teams, as they focused more and more on clickbait, on a very surface level of understanding of the kinds of things, that they were making themselves more generic and not really setting themselves apart from anyone else. And that could work for a few people. It could work for the New York Times, it could work for the Washington Post, but for the large part, it's not going to work for most of them, that they're going to get to the point that they really just don't understand the stories that they're working on. So I had assumed from day one that the dominant role of traditional media was temporary, and that we were going to shift to new media being the dominant role. I just didn't think it would take this long. Right? Like I thought it would take like maybe 5 years, right? Maybe 6 years. Like we get to a point where like, yeah, okay, people take their news seriously from the internet. But here we are 21 years later, and still people take CNN. People are more interested in hearing from CNN about space news than me. So I see that I need to just keep holding on. So my job is not to take other people on. My job is to not die, to not like be, I'm like I don't know.
You're the mouse waiting for the dinosaurs to be done.
I'm a cockroach. I am unkillable. And so, because I run Universe Today. Literally, I run Universe Today from a corner of my basement. The entire team is online around the world, set up wherever they want to be. We work completely virtually, and our expenses are, the price of the heat and my internet and what it costs to keep me in new computers. So it's, in terms of just like our expenses, we couldn't go lower in terms of operating expenses. And so I think that allows us to then just wait patiently for what we all know was inevitable,
Yeah.
just that it is taking longer than anyone ever expected.
And I feel like it's going full circle. As we record this episode, it will be airing tonight on Houston Now Media 21.10, because apparently television stations now have dots. Um, and and here we are taking what was an audio only podcast that ended up with video getting added, that ended up getting picked up for television in the opposite direction of where things started when you and I first began doing new media. And we found all these radio shows and TV shows joining us in the podcast directories. And we're putting out our Astronomy Cast show with a staff of 2 part-time humans and then the 2 of us.
Yeah.
And Daily Space, there's a whole whopping 4 of us involved in putting it together. And there are more camera humans on most news shows than we have total humans.
Yeah. Yeah, I mean, the infrastructure is like, I want to spend all my money in paying writers to write interesting stories. I want to spend every single penny that I have to spare on news.
Yeah.
And I don't want to spend any money on fancy gear. I don't want the gear to make it worse. But beyond that point, I don't really, it doesn't really bother me. So how can I get the most news possible and the best coverage and really kind of specialize on that? So yeah, no, I think it's, there's just like an existing infrastructure that a lot of these old media companies have. They have offices in Manhattan. They have studios. They have ways that they do things, and that has never been affordable for us in new media ever.
Right.
And I don't think ever will. Like, unfortunately, I think that the way we run things is the future for most things, because we're moving away from mass media and moving to a very specialized kind of media where people are really interested in a certain kinds of topics, certain kinds of things. There's people who do a great job in that area. They support them through advertising, through being patrons, through sponsorship and that kind of thing, so that they're able to continue doing their job, and less so just having more generic information just be playing in the background while you're doing other things. So I think people now choose their media very carefully, and those who are able to stand out will do well.
One of the things that I kind of love is we've had the opportunity to go to a few different launches, and we show up with backpacks of equipment instead of news vans with satellite dishes. And this gives us the freedom to run around and cover anything from anywhere, which is kind of amazing. But I don't know about you. I'm watching what the new kids on the block down at Boca Chica are doing, covering. Who do you look for now for inspiration as we get older to make sure that we don't end up being old media?
Yeah, exactly. Yeah. No, they're doing amazing. I mean, you look at what's happening with Everyday Astronaut and
NASA Spaceflight.
NASA Spaceflight is doing an amazing job. Yeah, they're doing a terrific job. And I mean, partly they have the advantage of being Americans. I'm a Canadian, so I can't even come into your country right now. But I do have partnerships. I mean, we send a photographer to most big launches. We're able to have local photographers who can attend launches at Cape Canaveral and stuff. But there's just like a level of dedication and live coverage. And I'm so grateful for the work that they're doing and the quality of the coverage, and that they are, I mean, the benefit that they're giving me is that they are helping to raise the overall knowledge and understanding of the current level of space flight and space exploration, to bring whole new communities into this entire field, get them excited about what's going on, and then people will be looking for other stuff. And yeah, I can't provide a live stream coverage of the latest SN flight, but I can tell you why it's important. We can cover all of the follow-on technologies, all of the other interesting stuff that surrounds it, and probably a bunch of stories that you've never heard. So I think that anything that really just raises overall awareness of what's happening in space and astronomy is just more, please. I mean, you and I we've always held to this, that
Yeah.
the more people who come into this field, the more people that come into this community, the better it makes the community. There literally is no such thing as competition. I don't even think about it. I'm just super excited, and I help them out every chance that I get, both Padre and Everyday Astronaut and NASA Spaceflight and Ars Technica. They're doing a phenomenal job.
We're not doing this in competition. We're doing this in celebration of one another's achievements. And that's one of the really awesome things. So what's the next big thing that you're coming out with that people should know about?
I sort of have shifted away. I don't really have a lot of big projects that I'm working on right now. I mean, I think the pandemic obviously has sort of changed what we're capable of accomplishing from the confines of our house and the borders of our country pre getting vaccinated.
Yeah.
I think once things are lifted, there's a lot of like interesting reporting and road trips and things like that I would really love to do. There's a lot of missions, a lot of places where interesting work is getting done that I'd love to be able to try and take the stories there. But beyond that, I mean, the big thing I'm working on is keeping my family safe, me safe, the website safe, keeping as many people as employed as I can, and helping everybody weather through this situation. If we get through this and everybody is at least the same, maybe mildly improved, then it's a tremendous victory.
I think that is a fabulous note to end on. It's been great having you here, Fraser, and we will be recording live on YouTube this Friday at 3 p.m. Eastern. And new science coming daily, weekly, and apparently for decades in the decades to come.
Yeah.
So this has been the Daily Space. If you want to learn more about all the stories that we've presented today, check out the images and get links to all of Fraser's sites. Check out our website, dailyspace.org. Thanks, everyone.
Did you know that children and adults are spending 90% of their time indoors? Whether at home or at the office, structures are now built tighter and more energy efficient, creating toxic environments.
Indoor pollution is 2 to 5 times worse than outdoors. Childhood asthma has increased 600% in the last 30 years. According to the EPA, there are over 750,000 new asthma cases every year in the United States.
Poor air quality can cause headaches, snoring, fatigue, sneezing, coughing, severe allergies, and much more. Additionally, chemical pollution from cleaning products such as bleach or Lysol and also treated building materials can severely affect your health.
Tactico is an indoor air quality company that focuses on health and wellness by using revolutionary technology to clear the air of toxic indoor pollution.
Our cutting-edge, green-certified solutions remove all odors, allergens, viruses, mold, toxic chemicals, and insects to create healthy homes and workplaces. Within minutes, our military-grade products kill 99.9999% of all toxins. Our team is highly experienced and is comprised of military veterans whose mission is to provide excellent customer service to our clients. Because your safety and your health are important to us. Call Tactico today, 832-901-9979, and let us create a healthy environment so that you and your family can live pollution-free.
Hello, and welcome to the Daily Space. I am your host, Beth Johnson, and I am here to put science in your brain. Today, Pamela is recovering from getting the first of her COVID vaccinations, and we wish her the best. One of the tricks with this show is digging up news, and in digging up news today, we found a bunch of science that actually required a fair amount of digging, or at least searching. And it all starts with a flash. On February 28th, a meteorite streaked across the sky over Northern Europe and the UK. This particular streak was caught on camera from a bunch of different sites, and the combined imagery allowed researchers to figure out where the space rock came from and where any surviving pieces may have landed. In this case, it landed in the driveway of a home in the small Cotswold town of Winchcombe. This was the first time in 30 years that a meteorite has been located in this way in the UK. And the particular bit that was found was a 300-gram carbonaceous chondrite fragment. This type of meteorite rarely survives to be identified on the surface of Earth. According to Ashley King, who was among the first researchers on the scene, nearly all meteorites come to us from asteroids, the leftover building blocks of the solar system, that can tell us how planets like the Earth formed. The opportunity to be one of the first people to see and study a meteorite that was recovered almost immediately after falling is a dream come true. Dr. Richard Greenwood captured the excitement of the moment, adding, "I was in shock when I saw it and immediately knew it was a rare meteorite and a totally unique event. It's emotional being the first one to confirm to the people standing in front of you that the thud they heard on their driveway overnight is, in fact, the real thing." After being collected in Winchcombe, this fallen space rock was taken to the Natural History Museum in London, where it will be further studied. This rock was recovered so quickly and in such pristine condition that this is essentially a free sample of an asteroid, not too different in quality from those brought back by Hayabusa 2. Although it will take a bit longer to sort exactly where in the solar system it came from. Finding this asteroid fragment wasn't that hard in the grand scheme of things. But the star, or rather the dead star of our next story, was more than a little surprising. Just 500 parsecs away, a giant supernova remnant was hiding in plain sight. Invisible to your everyday telescope, this object shines in the X-ray sky with an apparent size of 4 degrees. This is a middle-aged remnant that might appear like the Vela Nebula if it were differently located. This object was found with the eRosita All-Sky Survey and will be published in a new paper in astronomy and astrophysics. The research was led by Werner Becker, who named this object Heunga, which happens to be the medieval name of Becker's German hometown. While it is a bit disturbing to realize the second largest supernova remnant in the sky has been hanging out unseen for so long, it isn't actually surprising. It's estimated that galaxies like our Milky Way should contain about 1,200 supernova remnants, but so far, we've only found about 300. The majority of these are invisible to optical telescopes and have instead been discovered with radio telescopes, and now with X-ray facilities like this one. The eRosita All-Sky Survey is specifically designed to search for supernova remnants, and in the coming years, hopefully, we will find a lot more of the remnants hiding in plain sight, obscured by dust, gas, and light from other objects, or just faded away beyond our ability to see. It's really not possible to know what all exists out there among the stars, beyond our ability to see. One of the most commonly chased wild ideas is the wormhole. Mathematically, wormholes were devised by Hermann Weyl in 1928, but the term wormhole was coined in a 1957 paper by John Wheeler and Charles Misner. For most of her career, Pamela has repeatedly explained that actual wormholes shouldn't exist because they, according to the math she learned, would collapse when any matter or energy entered them unless some otherwise unneeded form of exotic matter exists. The thing is, until something is observed, there are always ways to tweak the math and devise new possibilities. A new paper in Physical Review Letters by Jose Luis Blasquez Salcedo, Christian Knoll, and Eugene Radu describes, and here I quote, a class of traversable wormholes without needing any form of exotic matter. This theory isn't without a catch, however. Their wormholes are constructed from just 2 massive particles. specifically two massive fermions, particles related to electrons or neutrinos, but bigger. And there is another catch. The matter passing through must have just the right amount of charge and mass. In this case, they devised a scenario where electrons are able to travel through a microscopic wormhole. Now, all because this is possible in math doesn't mean it's possible in reality, but there is nothing obvious to us or the peer reviewers to say this kind of wormhole can't exist. I'm just not sure how we're going to dig up these microscopic wormholes out there in the vastness of space. But that's a problem for another day. For today, we have one more study showing that the modern universe is expanding at 73 to 75 kilometers per second per megaparsec, a number that doesn't agree with what is happening in the early universe. Ever since this discrepancy was discovered, folks have been trying to find either an error in the observations or some other factor that would bring the different sets of measurements into agreement. The problem is every different way we have found to measure things in the modern universe keeps matching. Supernova results match lensing results, match, we learn now, the results of considering the average scatter in brightness of stars in elliptical galaxies. In a new paper in the Astrophysical Journal, a team led by John Blakesley looks at 63 of the 100 most massive galaxies within 100 megaparsecs of our galaxy. These systems should have similar stellar populations, and closer systems will have greater pixel-to-pixel variations. Essentially, we can clearly see their texture. Farther systems will appear smoother as more stars blur together in each pixel. Using these pixel-to-pixel variations, the team determined the distance to each galaxy. They separately also measured how fast each galaxy is being carried away from us by the expansion of the universe. Combining all this data and comparing it with other matches, everything still matches, and we are no closer to understanding why the expansion rate of the universe is different when you look at different times in the universe. It is all kind of a hot mess, literally. The universe is hot and it is messy. And after the break, we're going to dig into the particles from that universe that keep cascading onto our world. Stay tuned. Understanding our universe requires understanding how individual particles in the hearts of stars and in the first moments of existence have all been able to create the light that warms us and the particles that make up our planets, our technology, and even ourselves. It's hard to build massive telescopes, and the decade-long delay in the launch of the JWST is a case study in how hard it is to build scopes that allow us to see back to the earliest epochs of star and galaxy formation. On the other end of the scale, we build massive accelerators like Fermilab in Illinois and CERN in Europe, and we smash together particles after accelerating them to huge velocities. And out of the energy of the collisions, new particles can pop into existence. From these collisions, we've detected quarks, the Higgs boson, and myriad other particles. Unfortunately, there is a limit to what we can do, and some theorized reactions are beyond the capacity of our current engineering and our current power grid. Back in the 1960s, Sheldon Glashow predicted that at the right energy, an antineutrino and electron could interact and produce a W- boson. This unstable particle plays a role in nuclear decay, and the W- in particular, it lets quarks change flavors, literally make down become up, or at least the down quark to become the up quark. Every nuclear decay, for instance, in a cancer treatment or in the glowing radium hands of an antique watch, every nuclear decay is thanks to these particles. Now, we've been able to detect W- bosons with CERN and other accelerators since 1983. Electrons, well, Benjamin Franklin studied those, but antineutrinos are harder. We do have various detectors that can broadly detect neutrinos and antineutrinos, but we can't always figure out if we're seeing a neutrino or an antineutrino. Sheldon Glashow's prediction of an antineutrino interacting with an electron and W- boson offers a specific reaction that, if observed, will make it clear that an antineutrino is being seen. It isn't enough to mix these three particles together, however. The antineutrino in the reaction has to have just the right energy, an energy 1,000 times greater than what CERN can produce. This means, to see this reaction, the universe must accelerate an antineutrino to just the right energy, fire that antineutrino in Earth's direction, and that particle must intersect with an electron inside a detector capable of seeing the interaction. Basically, a lot of things in the universe have to precisely align. And on December 6, 2016, this is exactly what happened. Down in Antarctica at the Amundsen Scott South Pole Station, there are thousands of sensors distributed over a cubic kilometer of ice, watching for high-energy cosmic neutrinos and antineutrinos to interact and create cascades of particles and bits of energy. On that summer day, the specific cascade of particles distinctive of Sheldon Glashow's resonance was spotted, signifying that a 6.3 peta-electron volt antineutrino, likely accelerated by a massive black hole somewhere out in space, had precisely hit an electron. This result is now published in the journal Nature by the IceCube collaboration. According to researcher Lu Lu, previous measurements have not been sensitive to the difference between neutrinos and antineutrinos, so this result is the first direct measurement of an antineutrino. To me, this is amazing because so many things literally had to line up in time and space to allow this detection to happen. But because the universe is vast, the fact this has happened once means it should happen again and again and again. With each detection, we'll be able to better understand the ratio of how many neutrinos and antineutrinos are out there being accelerated our way. Just think, some of them could be passing through you right now, and you would never know. Science is weird. It is wonderful. And after the break, we'll be talking about the weird zodiacal light that sometimes lights the midnight sky. I'd almost argue that this story should be a part of our What's Up segment this week, since it's about an astronomy phenomenon photographers look for. But it's actually a science story about that phenomenon. I'm talking about zodiacal light. It's a faint glow in the sky just before dawn or just after dusk that happens when sunlight is reflected toward Earth through tiny dust particles that are orbiting the sun. I learned that these dust particles are the result of comets and asteroids shedding material when their orbits get too close to the sun. It's basically the same cause as our meteor showers, except that we're viewing the light through the dust from a distance instead of passing through the dust and sky watching late at night. Or so we thought. New research published in the Journal of Geophysical Research Planets examines data from NASA's Juno spacecraft that detected dust particle impacts as Juno traveled from Earth to Jupiter. The result is that the research team now thinks our zodiacal light is actually caused by dust particles from Mars. The discovery was actually quite serendipitous, as the press release headlines claim. The instruments on board Juno weren't designed to find dust particles. They were designed to take images of the sky every quarter second. These images help determine Juno's orientation in space by matching to star patterns, and that keeps the magnetometer's measurements accurate. But lead author John Leif Jorgensen also programmed one of the cameras to report when an object was found in multiple images that didn't match the catalog information. He was looking for undiscovered asteroids. What he found was image upon image of tiny streaks appearing and then disappearing. After eliminating several possibilities, including a possible fuel leak from Juno, the team realized they were looking at interplanetary dust particles, and due to Juno's gravity assists, they were able to actually compile a distribution of those particles. The dust basically stretches from Earth to just beyond Mars. Earth, it seems, pulls in the closest dust particles, and that's the cause of the zodiacal light. On the other end, Jupiter's gravity grabs the particles. The question remains, though, as to how Mars lost all these dust particles in the first place. It's pretty interesting research that no one is really doing. In fact, research on zodiacal light is sparse enough that Dr. Brian May of Queen fame was able to complete in 2007 the thesis he started in the early 1970s because no one had really done anything in the field since. That thesis was titled A Survey of Radial Velocities in the Zodiacal Dust Cloud. Maybe he'll help figure out this Mars question too. I'll be back in a moment for our weekly What's Up segment. Stay tuned. And now for another segment of What's Up. March is the beginning of what is called galaxy season. At this time of year, the Milky Way gets out of the way, making many galaxies easy to view in the Northern Hemisphere. Several impressive ones can easily be found at binoculars, including Messier 31, the Andromeda Galaxy. It is one of the easiest to find, as it is quite bright. In binoculars, it looks like a great gray blob, and if you have a telescope, you can tease out the dust lanes and other details the longer you can observe it. M31 can be found pretty easily. It is just up and to the right, left. We'll have star charts of the bright star Merak in the constellation Andromeda. I usually use the Great Square of Pegasus to find it. It's off to the side from the bottom left corner above Merak. Another galaxy visible in binoculars is M81, Bode's galaxy. It is located in the northern sky, about 2/3 of the way between the North Star Polaris and a little bit to the left of the scoop of the Big Dipper. It can be resolved in binoculars, but is best seen with a small telescope. Once you find M81, it should be easy to find M82, the Cigar Galaxy, since they're really close together in the sky. For this pair, you'll want to draw an imaginary line from the corner of the bowl of the Big Dipper below the handle, not next to, diagonally to the opposite corner, and then keep going out about the same distance. It might take a few tries if you're star hopping. I know it did for me. There is also much to look at in the night sky besides galaxies. Take advantage of the new moon coming this weekend, and once again, check out the Great Orion Nebula, M42. Find the 3 stars of Orion's belt, and then look for the sword hanging from the belt. In the middle of the sword is a bright cluster of objects, the largest of which is M42. It is very bright and puts on a good show in binoculars. M45, the Pleiades star cluster, is also still visible. If the sky is very clear, you will be able to see the 6 major stars of the cluster with your naked eye. You will see lots of stars in binoculars. Go from the belt of Orion to the V of Taurus and keep going. You might even be able to pick out the faint nebulosity of the cluster. Last but not least, the planet Mars is going to be visible all month. Look for the bright pinkish orange object in the western sky between sunset and midnight, about 1/3 of the way up from the horizon. This has been the Daily Space. Join us again tomorrow. You can find more information on all our stories, including star charts, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.
Are you a business owner feeling overwhelmed or burnt out with no energy left for what's most important to you? In order to effectively run your business and maximize your profits, you have got to be the best possible you that you can be. Now is the time to reclaim your energy, master your schedule, and maximize your profits so you can effectively run your business rather than it running you. It's time to become the CEO of your business and life. I'm Jen Godet, a business strategist and life coach. I work with overwhelmed business owners who feel stuck in a rut and depleted. I teach you how to stop doing the things that aren't making you money and start prioritizing the things that bring you energy, joy, and lasting impact. I'm a human performance specialist and an international best-selling author. I've helped countless people all over the world to learn the art of saying no, overcome their fear, and maximize their performance. Let's get you to live your best possible reality. Start today and become the CEO of your business and your life.
Hi, my name is Ranjit Makija. I run a CPA firm called Makija CPA LLC. We work on your accounting. We're not your average CPA firm. We work through our clients throughout the year. So we do on a monthly basis your bookkeeping, tax planning, and tax returns. By doing this all in-house by a CPA firm, we're able to actually figure out what's going on in your business, be able to reduce your taxes, and have understanding what's going on. Now, we also, if you have a part-time bookkeeper and you need to be able to figure out ways to reduce costs in your business, you can actually outsource all your accounting needs to our firm. And by doing that, we should be able to actually have a better add value to your business. So please give me a call. My phone number is 713-258-0196. Also, my email is ranjit@makh-accounting.com. Please give me a call so we can figure out ways to reduce your taxes.
My name is Brooks Boyd, and I'm the owner of Senior Savings Organization, a Medicare insurance agency. Medicare is confusing, it is not a one-size-fits-all plan, and I help folks navigate the maze. My main job is to educate so you pick the approach that feels right and make sure you avoid costly Medicare mistakes. I will help with transitioning from group health to Medicare with a personalized report to see if it makes sense to either stay on your current insurance or to consider enrolling into Medicare with either a supplement or a Medicare Advantage plan. And I'll explain the difference between the two and the pros and cons of each. If you need help with Social Security planning, I can show you how to maximize your benefits with the free Social Security Maximization Report to make sure that you are confident that you will get the most out of your Social Security benefits. I am an independent broker. This is a no-cost consultation, and you will never pay a fee with me.
Tienen muchísima lana y la mayoría no tiene casi nada. Pero las cosas están cambiando. Se han eliminado los privilegios, los lujos y se ha frenado en seco a la corrupción. Todavía queda mucho por hacer, pero el México de hoy va por el camino correcto. Y desde el PT seguiremos apoyando e impulsando la transformación que hemos iniciado por ti. El PT está de tu lado.
Escucha República H con Blanca Becerril.
Roy Campos, presidente de Consulta Mitofsky. ¿Cómo anda el presidente Andrés Manuel López Obrador en popularidad? ¿Le afectó, por ejemplo, ahorita que veníamos platicando del tema de Félix Salgado Macedonio, lo de que pues ya llegamos lamentablemente a más de 200,000 muertos por la pandemia? ¿Le afectó, no le afectó? ¿Sigue igual en popularidad? ¿Cómo anda?
Todo el tema del feminismo y la defensa de la mujer, de la violencia, todo ese tema, y ahí le pegó a López Obrador y le pegó fuerte. En febrero estaba en 59% y en marzo, recién pasado, llegó a estar abajo del 57%. 2,5 puntos le pegó. No es cualquier cosa. Claro. Son más de 2 millones de personas que de haber estado de acuerdo con él pasan a estar en desacuerdo. Entonces, sí le afectó. Pero luego iniciaste preguntándome cómo está la popularidad. Y resulta que lleva 15 días recuperándose de esa caída.
Lunes a viernes, 8 de la noche. Heraldo Radio.
Hoy hay tanta información que es difícil identificar la que es útil y si ayuda a tomar mejores decisiones.
Publicar noticias falsas